So if you need help on that class opener, you could watch the previous video that I posted. Okay, so let's move on. Right here we have a square root of 9. And what is the square root of 9 really? What's it really asking? It's asking what value times itself twice will give you the answer 9. And we know that the answer is 3, right? 3 times 3, 3 times itself gives you 9. And that's what the square root of 9 is, it's 3. Now, when we look at this, it's red with the 3 right here. That's no longer a square root. This is a square root, but this right here is a cube root. Okay? So what this is asking is what number times itself 3 times will give you the answer 8. So that answer would be 2, right? So the cube root of 8, or the third root of 8, that answer's 2. Why? Because 2 times 2 times 2 is 8. So it's the same thing as square roots. Like when I say what's the square root of 9, the answer is 3. Why? Because 3 times 3 is 9. The cube root of 8 is what? 2, because 2 times 2 times 2 is 8, right? What's the cube root of 27? 3, because 3 times 3 times 3 is 27, right? So cube root is where you take a number and multiply it with itself 3 times, okay? As opposed to square root, which you just multiply the number with itself twice, right? So back when we were dealing with square roots, we had a list of perfect square numbers, right? 4, 9, 16, 25, 36, and so on and so on. Right here, if you're dealing with cube roots, you might want to make a list of perfect cube numbers. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, right? 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 is 36. Times 6 is actually 216. And pretty much you don't need higher numbers. I mean, you might need higher numbers, but for the most part, just with these cube numbers, you'll be good at simplifying cube roots. So cube roots are very similar to square roots, and simplifying them are very similar as well. The cube root of a perfect cube number is a perfect answer, just like the square root of a perfect square number is a perfect answer. The cube root of a perfect cube number is a perfect answer. So ladies and gentlemen, right now go ahead and answer 1, 2, and 3. I want to hit pause. Go for it. So the answer number 1 is 3. Why? Because 3 times itself 3 times. 3 times 3 is 9, times 3 is 27. The answer number 2 is 5, because 5 times 5 is 25, and 25 times 5 is 125. And the answer number 3 is 4, because 4 times 4 is 16, and 16 times 4 takes you back to the 64. So cube roots, when you take the cube root of a perfect cube number, you get a nice, beautiful answer. Now, if you are taking the cube root of a non-perfect cube number, you could rewrite it with multiplication to get a perfect cube number. Almost like square roots, right? When you don't have a perfect square number, you rewrite it with multiplication to get perfect square numbers. Right here, if you are taking the cube root, and if you don't have a perfect cube number, like 54 is not a perfect cube number. So we want to rewrite it with multiplication to get that perfect cube number. So again, a perfect cube number list will help us. Let's do that. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Let's just stop right there for now. Now let's keep going. What's 5 times 5 times 5? 25. And 6 times 6 times 6? 216. All right. So 54 is not on this list. So I'm going to rewrite 54 as 8 times something?
27.
No. 27 times what? 27 times 2. So let's rewrite it as 27 times 2. And what we're going to do is we're going to split the third root. And the third root of 27, this guy, what's the third root of 27? 3. And the third root of 2, you can't do it, so you leave it. So your answer is 3 third root of 2.
There's no such thing as a tree anymore.
What was that?
Like the tree is no good no more?
The tree is no good no more. Actually, that's an excellent question. Let's go back to this, and let's do it with the tree if you'd like. All right? Now, I don't want to confuse people. If you're good with what I'm doing, you don't have to do the tree, right? But if you're struggling and you love the tree, then pay attention here. 54, let's break that down into anything you want. 2 times what? 2 times 27. What does 27 break down to? 9 times 3, right? What does 9 break down to? 3 times 3. Now, since we're dealing with perfect cube numbers, not perfect cube numbers, since we're dealing with cube roots, what you're going to be able to pull out of the cube root is what repeats 3 times. So check it out. On your factor tree, you have 2, 3, 3, 3. What repeats 3 times?
3.
These 3's. So the 3's are going to be able to come out of that perfect, or out of the cube root. And what's left over? This 2, so the 2's in there. It's the same thing, but instead of square roots where you want to pair them up, you have cube roots where you want to get three of a kind that you're able to pull out of that third root.
So we can still do it that way.
You could still do the factor tree if you'd like. I prefer just dealing with the perfect cube numbers. Anyway, we already did number 1. I don't know why I erased it. I apologize. Let's jump to number 2 right here. Say again? Yeah, if we look at our perfect cube list, 125 works great. 125 times 2. 125 times 2. And if you split the third root, the cube root of 125 is 5. And the cube root of 2 is the cube root of 2. It stays like that. So the answer would be this. No? Do you guys want to try the factor tree on this one?
No.
Okay. So I know some of us are confused. All right, we're barely warming up with this. Number 3, we have the cube root of 40. Now 40 is not a perfect cube number. So if it were the square root, then you want a perfect square number. But it's a cube root, so you want a perfect cube number, right? So 8 times 5 is the right combo. So if I go 8 times 5 and I split the third root, then this first one, the cube root of 8, that becomes 2, and the cube root of 5 stays the cube root of 5.
Do you have to write 3 up there?
You have to write the 3 right in between this. Yeah, remember, cube roots, instead of square roots, cube roots are asking you what times itself 3 times will give you the inside number. So when I look at this problem, the cube root, the 3 is right there, the cube root of 8, it's not saying what times itself is 8. It's saying what times itself 3 times is 8. So it's 2 times 2, which is 4, times 2, which is 8. So that's why the cube root of 8 is 2. Cool?
Is there such thing as decimals? Square roots?
Yes, but we're not. All square roots or cube roots or fourth roots, all of those technically are either nice numbers or decimals, but they're irrational. And that's why we don't write them as decimals. We leave them as simplified radicals. Okay? Anyway, let's say you wanted to do number 3 with the factor tree. All right? The cube root of 40, just to show you. The cube root of 40, put a 3 right there. So if you just start breaking it down, 2 times 20, 2 times 10, 2 times 5. And we're dealing with cube roots, and we look at what we have. We have a 2, a 2, a 2, and a 5. So the 3 means that you want things that repeat 3 times. That way you could pull it out. So here's the cube root, and we're pulling out the 2 that repeated 3 times. 2 on the outside, and the 5 stays on the inside.
So if it was 4,
If it were the fourth root, it'd be repeating 4 times that you want to pull out. Good. If you're good the other way without the factor tree, you don't have to use the factor tree. I don't like using the factor tree, but if it's good for you, go for it. Okay. Let's move on here. Let me go. Okay. As a matter of fact, instead of moving on, I'm going to stop the video right here. I want to keep videos shorter. That way I don't get like a ginormous video. You guys could take it a piece at a time. So I want to start the next video right here, picking up on this set of notes.